Hello everyone! In this video we are going to explore Substrate or Strata Materials. I am currently using Unreal 5.5 and in this version we have Substrate in beta. So I thought this will be the right time to explore what a Substrate actually is about and how can we utilize this in our projects. So without further ado, let's get started. So, Substrate is a new approach of working with the materials which replaces the old shading models and blending modes such as the default lid, the clear coat, translucent modes, and it replaces with a more expressive and a really modular framework. Now, materials and substrates are conceptualized as slabs of matter, hence you will find the slab word in most of the nodes while using substrate. Now these slabs are called as BSDF, which is called as the bidirectional scattering distribution function, which we will learn more about it once we have a look at all the nodes the substrate has. So I am here in the content examples project for Unreal 5.5 and by default substrate is disabled. If you want to enable substrate for the project, you have to go to the edit project settings, and inside the engine and rendering you can find substrate. So you just have to scroll down, or you can just search at the top. You will find all these options. You can go ahead and enable substrate. As I said before, substrate is now in beta stage, and you can also go ahead and enable the other options over here. So after you enable this, it is going to prompt you to restart your editor, and it is going to take around 5 to 10 minutes depending upon the amount of materials and shaders you have in your project. And what it will do is automatically convert all the previous materials to substrate materials. So if I go ahead and check any one of the materials over here, you will find that the structure of the materials has been changed, and you will find there is a new node, so which is the substrate shading model. This node has been replaced by the previous node, and we have this new node over here, the resultant node. So we do have all the materials over here converted to substrate. Now keep that in mind. Opening a non-substrate material in a substrate enabled project, it will automatically convert it into a legacy substrate material, right? So it has already converted over here, but the conversion is permanent and cannot be reverted to a non-substrate material. So substrate materials renders black if substrate is disabled for the project. Alright, so these are the things you have to keep in mind. Alright, so here I am inside the material substrate level, which you can find in the content drawer, maps, and inside the material folder right over here. Now starting with, we have the introduction about the substrate material, and it is not in experimental, it is in beta stage now, and it is saying that we should enable the opaque material rough refraction and advanced visualization shaders. So we have already enabled all those options in the project settings, and also they have set the substrate bytes per pixel to 128. Before it was set to 80. So what is this substrate bytes per pixel? So it is a variable which is set to 80 bytes per pixel by default. If you increase it, it can be increased for complex materials with higher storage requirements. So they have increased it to showcase all these materials perfectly, right? So of course the higher value will use more memory and can affect memory bandwidth and also will affect performance. So how can you set this? You go to the console command and type r.substrate dot bytes per pixel right over here, and space. So current value is set to 128 as it is set by this level. Let's understand why substrate materials was introduced and what are the limitations of the legacy materials. So one of the major reason was the Unreal shading models in the legacy materials. Whenever you were creating a materials using legacy materials, you could only use one shading model. For example, you could only use a material based on a default lid, based on clear coat or a cloth, but you could not mix both of them. You cannot use both of them in one material. So substrates make that happen. Either in Substrate we could do vertical layering and horizontal blending, and which actually is really useful if you want to create some complex materials. Here we have the legacy material shading models. We have default lit, subsurface, cloth, clear coat. All of these are there in Substrate, but the advantage is we can now perform blending and layering, mixing between all of these shading models, which was not possible in the legacy materials. Here's the example of layering and mixing using Substrate. So we have this material A, which is like a golden metallic material with some texture on it. Here we have material B, which is a rough texture with rough material with some texture on it as well. Now when we do layering, so over here layer B on top of A, so this will be the base and this will be the top layer. So here you can have a look at, we have the base material B and then we have a top material A. So we can now see both of them textures on top of each other. Here we have the example of mixing A and B. So here we are just mixing the material A and material B. You can decide the amount of mixture as well. Here we have the example of adding and weighting. Now this is the material A, same what we saw previously, material B. Adding over here, you can see we have both of the properties right over here. Both textures are there. And we have weight. Now weight and the mixing is not the same. So what weight will decide is actually how much area does B cover and how much area will A cover. That is what the weight will decide. Now we'll have a look at the substrate nodes. So let's create a substrate material first. I'll open up the content drawer. Inside a materials folder, right click on material to create a sample material. I'll create a sample material and we have an empty material right over here. You'll find we have two new windows over here. We have a stats window and a substrate window, both of them for actually visualizing the performance of all the nodes that you are using, so that you can optimize this as well. Over here you will have a look at the resultant node of the material, which is now a lot of different, and we have another node over here which is saying substrate UE4 default shading. So this actually represents the legacy materials attributes. So you will be familiar with all these names over here, which was actually the same of the legacy materials. If you click on this, you will find we have a material function over here. If I double click on this, you will find inside this they are actually using substrate, because now we have converted all the materials. The entire project is now substrate. So if you want to use the if you are familiar with the legacy materials, you can just use all of these nodes and you will have the same output right over here. So that is why they have given this node, which is actually useful, and they are using the substrate simple substrate slabs over here to replace that. I'll click on the resultant node of the material over here and we'll look at the details panel, starting with the material domain, which is now set to default as surface. We cannot change anything over here. In the blend mode, we have few options. The opaque is the same opaque that we had in the legacy materials. When you select this, of course, the surface, the light will not pass through this. The masked, here we'll have to selectively control the visibility using binary. White means it will be visible, black means it won't be visible. Then we have translucent gray transmittance. Now this one, if you compare to the legacy materials blending mode, it is compared as the translucent blend mode. The additive is the same as in the legacy material, the additive mode. Then we have the color transmittance only. Now this one, if you compare, it will be used as the multiply blend node. We have the alpha composite, alpha holdout, same as we had in the legacy materials. Then we have the translucent color transmittance. If you compare this can be used as the thin translucent shading model that we used in the legacy material. The translucent gray transmittance is much more faster than the color transmittance, of course. The shading models is of course now grayed out because we can select it right from here. Then two-sided node is here, the thin surface, use material attributes we can select, and we can have a subsurface profile, and most of the things are same over here. Alright, now we'll have a look at the BSDF nodes. I'll right click over here and search for substrate, and you'll find we have lots of nodes. We have substrate operator nodes, helper nodes, extra, conversion, building blocks, BSDFs. So we're interested in the BSDFs first. So the basic substrate node is the substrate slab node, which is a simple default substrate slab node. Now substrate slab, imagine this like a block, and it is divided into two parts fundamentally. So one part is the interface or the top layer, and we have a medium, which is the bottom part or the base layer. So the interface top layer over here, it is represented as the diffuse albedo, the F0, F90, roughness, anisotropy, normal, and tangent. All of these are considered as the interface. Then we have the medium part, which is the bottom base part. Now this part is where the light will get scattered into the surface, it will get transmitted or absorbed. All of these will be controlled by the subsurface scattering mean free path, all three nodes over here. And the rest of the nodes are also a part of the top layer. Like we have the emissive color, we have second roughness, we have fuzziness, you can add fuzz roughness, then we also have glints that you can add. So this is the basic structure of the substrate slab. We'll have a look at what all of these nodes or the parameters does. I'll just delete the UE4 default shading node and connect the substrate simple BSDF right over here. Now remember, whatever calculations you do of the substrate, make sure the output node is always connected to the front material of the resulted material node. I just save this and I will create a basic shape of sphere. I will drag and drop, and I will apply this on the sphere. Just drag and drop. Alright, let's open this material, minimize this right over here, and let's have a look at the attributes. So the diffuse albedo is the base color. So right click and search for constant vector 3. 3 colors means RGB right over here. Connect this over here, double click, or you can click over here, choose the desired color and hit OK, and you hit apply over here. It will automatically apply to this sphere. So basic base color over here. You can also use a shortcut for the constant 3 vector. Just hit the 3 key while holding this, press the left mouse button, and this will just spawn. Then we have the F0 and F90 node. Now both of these nodes are related with the specular highlight, where F0 and F90 is the angle at which the surface is in related with the camera. So the F0 node will define the color and the brightness of the specular highlight, where the surface is actually perpendicular with the camera. So basically the center of the surface it will be. And the F90 node will define the color of the specular highlight, where the surface normal is 90 degrees from the camera. So basically that will be the edges of the surface. So for example, in the F90 node, where we can define the color, let us just remove it from the diffuse albedo and connect it to the F90 node, and I hit save. You can visualize it much better right over here, but if you look closely you will find the reddish shade over here. Let us just visualize it over here. So as you can see, we have the red highlights at the edges right over here, and the F90, if I disconnect it over here and connect the F0, sorry, and the F0, you'll see it is basically the entire thing, but it is mainly in the center, and the F90 is in the edges. So those were the F0 and F90 nodes. Then we have the basic roughness node. So you can just use a constant, so just search for constant, and if you reduce the roughness to 0, it will be highly reflective, and if you increase it, of course, it will be highly rough surface. Okay, so if I make this like 0.1, it will be reflective, and at the edges we can give a color. I'll hit Ctrl D to duplicate this. Let me actually bring this down. We can add a different color, maybe bluish color, right over here, and connect it. I'll add the diffuse albedo over here, and we can use a constant to give brightness to the center, so specular brightness. So I'll give it maybe like 0.5 to the F0. So now it is looking somewhat like this. You can see the edges, we have this bluish tone in the specular highlights. Then in the center also we have something bright. If I just disconnect this, you'll see it is just the base color over here. If I connect this, we can have the specular highlights right over here. If I increase this, it will be much more bright, as you can see. So yeah, you can use these combinations to create some amazing materials. If I save this and if I have a look in the viewport, it might not look the exact same because the lighting conditions are different, but you will find it pretty interesting. So these were the F0, F90 and the roughness node. So the anisotropy will actually control how the actual reflection will look on the surface. So the positive value will elongate the specular lobe along the tangent vector, negative value elongates the specular lobe along the perpendicular of the tangent. So basically, if I'll take the constant right over here and connect it to the anisotropy, 0 is default. I set to 1. Just have a look at the change in the reflection. So it is looking somewhat like this. So horizontally it has been stretched. If I do -1, you will see vertically it is being stretched. So that is how you can change the direction or the way the reflection will look on the surface. That is the anisotropy. I just set it to the default. The normal node can be attached with the normal map, so we can have some depth on the surface. So right click and search for texture sample, and here you can add a normal map. So search for _normal and we can find a normal map. So I'll select this base style normal. The sampler type is normal. If I double click and open this up, and I'm assuming that we will have a base style as well. So this is what the base texture looks like, and this is what its normal looks like. So the normal map is nothing but the light data of how if the light is coming from this direction, how it should look like on this surface. So it should look somewhat like this, and it will give the depth. So more pink right over here, you see that is where the more depth will be. So as you can see, these are the creases from this data right over here. So if I attach this to the normal node, you will find we have more depth on the creases, right? So that is what the normal map does. So I will just delete this. Next we have the subsurface scattering mean free path. Now this one right here, we have a node for this. So just search for mean free path. In the substrate helpers, you will find substrate transmittance to mean free path, and here we will find the mean free path. I'll connect this right over here. So what this mean free path will do, it will control the density of the material, like how when the light enters the surface, if the surface is translucent, right? When the light enters the surface, how will the light scatter inside, how will the light be absorbed inside? That is what you can calculate right over here. It defines the average distance at which the light interacts with the matter. So let's have a look how this will work. So for this you have to convert from opaque to translucent. Then we'll have a look at, you see how it is transparent. Now if I just disconnect this, you see it is basically opaque, right? If I give it some constant value, if I hover over this, you will see that it takes usually takes a float 3, right? If I just connect this constant and give value 1, you see it is now really transparent. But basically it will work, it is mostly used with the either it is used with the thin substrate thin film, it can be used with this as well, but here we'll use this with mean free path, so it will return the mean free path. And here you can add the constant vector 3, so constant vector 3, and if I attach it right over here, if it is black you will see it is totally opaque, but then we can, if it is purely white, it will be purely transparent. So maximum it is transparent, and you can control it from here. It will be less, little more opaque, right? So, and the thickness is the desired color transmittance is reached. It is the calculation of when it will be reached. So you can see the thickness. So at the center it is more translucent, and at the edges it is more opaque. That can be controlled in the thickness. So we can try this, set this to 0, and you'll see if I set this to 1, it will look somewhat like this. So that is what you can control in the thickness, and then you can return this thickness to any other parameter, to maybe the scale. So the main free path scale is actually the radius, and the anisotropy is basically what we it is same right over here, but for the translucent. Then let me just get back to the opaque. All right, then we have the emissive color. It's the same, it will add luminescence to your material. It will add some light, set to 0.5. It will glow, as you can see. And if you want to glow it with the color, just multiply this with an intensity, and it will do the emissiveness with the color. All right. One thing I forgot to mention is the subsurface scattering mean free path and mean free path scale will only work when the subsurface profile is not been added. All right. Then we have the second roughness, so we can get let's make it more rough over here. So let me just duplicate this one, and let us just bring it to the side. Second roughness, let us put this to 0. It will be more reflective. If I set this to 1, you will find it will be rough from the edges mostly. Let us just increase the roughness over here to 1 as well, and this specularity I will set this to 0.01. So now it is more rough. Then we have the roughness weight, is the mix factor between the primary roughness and the secondary roughness. You can give more weightage to the secondary roughness or the primary roughness. That is what you can define over here. Then we have fuzz roughness. So it controls how rough the fuzzy layer is. Okay, 0 means more shinier, 1 means more rough or matte, right? So also one thing, if you do not set the fuzzy amount, it will automatically take the second roughness. If you set the second roughness, I don't think it will take the fuzz roughness. And we have the fuzz amount, and we can get the fuzz color as well. Let's have a look at some more examples from this level, starting with irresidence. So it is a wave optical phenomenon caused by the light when it reflects off different layers of film, resulting in emergence of constructive or destructive interference pattern. So for example, they have shown when you see an oil appears on water, or soap bubbles, and oxidization of metal. Those are the examples. Over here we can see irresidence on translucent material. You can see this oil kind of pattern, which is actually a texture. We'll have a look at how this is working. So irresidence, a thin film interference, which is reclassified in substrate as a helper node. So, and it is also using index of refraction. So IOR, index of refraction, right over here. So if you click on this, so you need to set few things up right over here. Starting the blend mode is set to translucent, and they have set the two-sided to true. Then if you scroll down, you will also find the lighting mode is changed because we are using translucency. The lighting mode has been changed to surface forward shading to make sure we get the effect of a glass or water, right? So let's have a quick look at how this is made. It's looking pretty interesting. So starting with the mean free path, they are using the substrate transmittance to mean free path, and they're just using a white color over here. They have added the second roughness to 0.1, and the weight is equal between both. We have a normal map over here. So this is the normal map, and they are using Penner to actually animate this. So I can set this to 0.1 and this to 0.01 or something, to, you know, the oil will flow across the, as you can see, it will flow across. So you're just animating the normal map right over here. And here is the roughness. As you can see, we have the roughness of 0.05, 0.025, and here they're using rotator. On top of this, they are looping this, and here they are setting the index of refraction, and the F0 and F90 node is being set by substrate thin film, right? And here the F0, we have some value. Index of refraction is 1.8. I don't remember 1.8 is this of oil. 1.2 is of water, I suppose. But yeah, and here they have set it to the front material, and hence we are getting this amazing looking material right over here. Okay, let's save this and have a look. Right over here we have the irresidence on the translucent material, then irresidence on a metal surface. Oh, here they're using opaque and nothing else is changed, and because it is opaque, they are not using mean free path, but they are still using the thin film to get the irresidence. So you can see at the edges they have this purple kind of shade, which they are getting from the thin film effect. They are getting thickness and index of reflection. If I change the index of reflection to like 0.5, you see the effect will totally change right over here, as you can see. So index of refraction 1.8. Then over here, we have irresidence on dielectric material. somewhat looking like this. Those were the examples of irresidence and how to use thin film. Then we have some domain materials which we cannot be used in substrate. So these are some materials which are directly analogous and to their non-substrate equivalents. However, using them with substrate will automatically set the appropriate material domain and shading model. So they can be used but cannot be used in the substrate. It can be used in the isolation. So for example, the post-process material, light functions, decals, and so all of these are considered as the domain materials. So this is a post-process material. You can see we have this glitch, a kind of chromatic aberration over here. When using substrate, any material graph can be used as decal to ensure that the appearance is interpreted correctly. Convert to decal node. So this node you can use to convert any material graph used as a decal. And we have some monolithic material BSDF, volumetric BSDF, hair BSDF, eye BSDF, and unlit BSDF is also there. So if I open up the material, content material, if I open up our material, right click and just search for BSDF, you'll see we have eye, hair, unlit BSDF. So all of these will have preset of BSDF. The slab will have all of them. Then we have the clear coat. So all of them will have something related to their shading model basically. Here we have the introduction of the substrate slab. So the slab is the elementary building block from which one assembles a substrate material. As I mentioned before, it is divided into two parts, the top layer and the bottom layer. Top layer is the interface and the bottom layer can be considered as a medium. So here we have the example of the one material called as opalescent flakes. So let's have a look at this interesting looking material. So we'll click on this. Here we have the material. And you will find they are using this vertical layer, substrate vertical layer. So what this does, it takes input as the top layer, bottom layer, and the top thickness. So the top layer is somewhat like this. So if you look closely over here, you will find you can find the depth between the top layer and the bottom layer. So the top layer, it is some reflective kind of material, and the bottom layer is this glitter shininess, right? So if I look at them separately, so I will just connect the top layer directly, you'll find we have this reflective kind of material. If we look separately, we have the albedo to 0, roughness to like 0.125, then we have a normal map, then the mean free path, it's connected to a texture and just using a default thickness as well. So this is the top material, and the bottom material looks somewhat like this, which is this specular looking flakes they are calling it as. So diffuse albedo set to 0, f0 set to 1, okay, f90 set to default. Then we have a glint density set to 6, and the glint UVs they are using set to 512, and it is using the texture coordinate. Okay, and also you'll find this BSDF is complex and this one is simple. So if you search for complex, you will not find, because what makes it as a complex BSDF is because they are using here a specular profile. Over here we do not have any specular profile, but here they are using a specular profile to add color variation on top of this, on the specular highlights. So here we have a view color, and here they have the light color. So if I, for example, you can see it is greenish right over here, which is the light color, and right over here, if I just double click and change this color to somewhat like this and hit save, you'll find it change right over here. Okay, so the light color is just affecting the specular F0 right over here. So this material also really looking nice. So when both of them is used in top layer. So this one, so this one will be the bottom layer and this one will be the top layer, and then we attach it to this. It will look like a box, a ball covered inside a glass, right? So mentioning that we are using opaque right over here, but it still looks like we have a glass material and we have a depth inside, and looks really nice. You can save this, and when seen in the viewport, it's looking somewhat like this. Then we have chromatic specular. So if I click on this, we have a simple BSDF right over here. They're using a thin film, right? And object gradient they are using. So if I click on this, so it will use a gradient according to the world position and the object position. It is just giving us a gradient. All right, so it's nice that they have given us these material functions. We can reuse it in our projects, right? So they're just using the object gradient over here, masking it, adding it to the thin film, adding the roughness from 0.32 to 0.56. So yeah, and the base color is right over here set. If you set this to white, then we will see more of the gradient. Yep, somewhat like this. Yeah, this material is also pretty interesting. Right, then we have the oiled leather material, where they have this car seat, and they have this leather. So they are using a textile master material, which is a parent material, and it seems pretty complex, but you can use this textile master material, and then you can create a material instance, and you can add your own twist to it. They are using this base color, they are having this leather texture to it, right? You can change the color of this, and yeah, it's also pretty interesting. So if you are using cloth, you can take this off. So yeah, this was basic substrate slab. So here they introduced you with the vertical layer, right? We'll have a quick look at the other examples they had given in this project. We have the opaque blend modes, so default opaque. Then we have the masked. So the mask means the white values will be visible and the black values will be hidden, as you can see. Then we have the opaque rough refraction to give like a blurry effect. Here they are using vertical layering. Slab, here they are using albedo plus f0 and slab plus metallic helper node. Now both of them will look same, but the way of implementing is different. Over here they are using a constant vector 3. Both of them are the constant 3 vectors, and we have this output. Whereas in this one they are using this node, substrate metalness to diffuse albedo f0. So two ways to implement, but both of them looks pretty much the same. Then the anisotropy, we have, as I said before, we have the negative values and the positive values for this to actually change how to change how it will reflect on the surface, how the light will reflect on the surface. So it is looking somewhat like this. So pi tangent looks somewhat like this. So yeah, you can just play with the values to make it look to your desired reflective material. So mean free path, so subsurface profile, which is just the default one. They're using a demo subsurface profile right over here. Then they have mapped mean free path for subsurface profile. So I open this up. Here they are using the mean free path with the object gradient. Subsurface scattering, two-sided lighting, second roughness. So how you can use second roughness, and you can add the weight to control between the first roughness and the second roughness, right? Then we have a simple clear code. So a simple clear code, we have a BSDF node for this. So it is a different BSDF node. Search for BSDF, you will find the simple clear code right over here. So if you want to create a kind of a paint material, you can use this clear coat material, which looks really nice. Then we have a layer on top of clear coat. So as you can see, so there we are using some layer. So they're using a vertical layer, but they're using a horizontal blend as well. So it looks somewhat like this. So the horizontal blending is happening in between. Actually, I changed it before to visualize. So the horizontal blending is happening in between this fake caustics and the water droplets right over here. And if we just connect this to the front material, so it is looking somewhat like this. And then they are using vertical layer on top of this. So the car paint. So the car paint has water droplets and some caustics. So yeah, you can use blending between both of them, and then they are having mix, and then they are using weight of the droplet mask. How much droplets do you want on top of the caustics? So yeah, interesting. Then we have the mix with clear coat. So over here, let's have a quick look. They're using horizontal blending and they are mixing with a dust mask, right? If you look at these things, yeah, it's also interesting. So using horizontal blend, they can achieve somewhat like this. Then we have fuzzy shading. So you can have fuzzy roughness and the amount with the color. We can change the color from here, set it like blue. You can have a bluish tint to the fuzziness, as you can see. So right over here, few examples on lookup textures, LUTs. We have few examples on glints. Then we have substrate translucency. We have translucent opaque object, how you can create this material. So they are using translucent blend mode. Here they're using BSDF simple. They have some roughness and the index of refraction. So I suppose over here they are using, you scroll down here, the refraction method is set to index of refraction. Hence we have this node we can set. Then we have translucent coverage. So here if we have a look, we can use this weight node to actually see how much weightage you can add to this material. So if I increase or decrease, if I set this to 2, then we'll have somewhat like this. Let it load. But if I want more of this weightage, so I'll just increase its UV tiling. Basically I'll make it like 8 or 16. So we'll have more of the blocks over here, somewhat like this. So basically it is like masked, but we are using it with coverage weight right over here. Then we have translucent transmittance. Then we have translucent layered. So we can have a look at this as well. They are using horizontal blending with a dust mask. So yeah, also pretty interesting. You can see the dust mask on top over here. We have grayscale transmittance, chromatic transmittance. So yeah, a lot of examples. So alpha holdout, which is same with the legacy materials. Rough refraction. So here we have like a frosted glass effect, right? I click on this. we have this frosted glass kind of effect. We can achieve this using mean free path, and we have some roughness. Yeah, pretty simple, and you can use refraction over here to get this frosted glass effect. So advanced substrate use cases, so we have some examples that we can have a look at what extent we can use substrate. Yeah, you can see we have vertical layer, we have some switch cases over here, and yeah, carbon fiber materials. So we can just learn from all of these, and maybe in future I'll create a tutorial on how to create somewhat like this wet sand and water, which is also pretty interesting. You can see how it is. So it will go, and yeah, it will dry, and then it will wet the sand. So now the sand is getting dry, and then the sand will get wet. So yeah, it is also amazingly created. We have some vertical layers. So yeah, lots of complex substrates going on over here. All right. So yeah, this is one of the material being used in the Rivian car model. I'm suppose this is the right one. So the opal material. Yep, I'm sure that this is the one they used in the Rivian car model in the Electric Dreams project. Graph topology limitation, we have substrate in material function. So yeah, the default UE4 and all of these are the material function basically. So this one, if you click, these are the material function of substrate. So if I right click and search for substrate, and where we can find this UE4 legacy, we just, yep, this one right here. These are basically coming under building blocks. So all of these are actually material function, right? So these are the material function they have already created for us to to simplify things. Basically, if you want to use a coated material, you can just use this material function, and then you can customize all of these parameters, and boom, you will get this easily. So all of these are for supporting the legacy shading models, because if you are familiar with the UE4, I mean the legacy materials, and you will be easily using the substrate with help of this. So yeah, these were the overview of substrate and how to use substrate, just the basic use case of substrate. Let me know what other tutorials would you like me to create. If you want to learn more about substrate, let me know. I'll create some in-depth tutorials on how to create some advanced materials using substrate. So yeah, thank you so much for watching this explanation video, and stay tuned for more.